My name is Juan Sebastian Ruiz Villa. That's four names. That's one really Latino thing. And today we're going to be talking about a Terraform-Powered Platform-as-a-Service. So first of all, there's been great talks, and I'm sure that everyone has been getting knowledge like fed from a fire hose. So I'm going to try to boil down this to the most important aspects of it. And just without further ado, let's get started. And first of all, I work as a DevOps consultant in a Colombian outsourcing company called PSL. I work with several projects and several clients and help them increase their DevOps adoption levels, and ranging from cloud cost estimations and just straight up and making processes better for software operations and delivery. This is my GitHub handle. You're more than welcome to check out the stuff. So just to start, we're talking about a platform as a service, but let's define platform, like a platform as a service on its own. So first of all, a platform as a service would be something that we have for customers that will encompass some compute resources, some, virtual network resources independent on the level we want to offer, some software artifacts running on our compute resources perhaps, some access control policies, showing IAM, just to give you hints that it's AWS based, and some data storage. And for the sake of this argument, we're gonna deal with one that is AWS based. Just so you know, this is coming from a real case that we have with one of the clients. So we're going to be doing some, like laying down some of the experiences we've gone down with this implementation so far. Even before having a complete perfect solution from the get-go, the development of this have been a little bit more realistic in the sense that we've been learning along the way, and we know we're still a little bit away from our end goal. But we do think this experiences are going to be really valuable for you, and I hope they will be. So again, platform as a service. For the time being, we're just I just wanted to find the platform we wanted to have for our customers, offer to our customers as a very simple runtime environment our customers will use to develop, let's say, everything ranging from Go to Python. Just think about it as a hacker rank, but a little bit more data oriented. So if we boil down this to its basic components, we would have a front end that's going to have the full-on front end for the platform that our customers are going to use. And then it's going to have a back end that's going to be served. By the way, again, this is all AWS based. So if you see some really not that agnostic services in there, I apologize. I just want you to lay down the concepts. And the backend is going to be served from an Amazon API gateway. It's going to go through a load balancer. It's going to go through the actual backend server that's going to be dealing with all the business logics that then are going to take whatever the customers are going to be developing, and it's going to execute that through Lambda. So the complexity has been pulled down to this version of the architecture, but for the sake of the offering and the platform and the actual infrastructure, let's just think of this as a bunch of infrastructural resources. I'm pretty sure there's might be people listening to this that are building similar systems and just got a little bit mad at me because I'm grossly oversimplifying the actual work that goes into deploying and maintaining one of these. But for the sake of the argument, let's just assume this is just like a little box of infrastructural components, right? So now we have our platform. That's the service we're going to be offering to our customers. But for us to make a business case on it, we got to have automatic provisioning. And automatic provisioning will go ranging from all the VPC resources, the load balancer connections, the scaling policies, the databases, even all the schema, and everything needs to set in a one-click deployment. So we came up with a really simple and not so elegant solution for the time being. We'll just go for it. But our current situation, at least with the client I'm working on this specifically, it's that we have a very good expertise in Terraform and a very extensive use. We're using it through all the life cycle on all the software we're doing. Central, so it's separate code. We've bundled it together to each and every application we're working on. It's just the central Terraform code base, and that has its own disadvantages and advantages. One of the things that we're subjected to is very strict operational standards. So that way we can completely be sure that the modules that are being used are the ones that were centrally sanctioned and that have all the policies that we want to ensure across all our ecosystems or all the clients' ecosystem. The first problem when talking about automatic provisioning of Terraform code or automatic generation, which is what we're going to be dwelling into a little later, it's maintaining the coding and infrastructure. See, our entire code base, it's managed by hand by a centralized group of operations engineers and cloud architects and engineers. So when you're doing that by hand, you definitely get into some standards and you get accustomed to some verifications that you need to ensure when you're trying to automate that piece. So currently, one of those standards is that we're using feature branches to develop this infrastructure and develop the Terraform code. And one of the things is that everything that gets merged into the main line or into the main code base needs to be already applied. So that way we're sure that the operations engineer that was building the infrastructure, deploying it, actually left the main branch in a stable condition or in the latest stable state. So that is one of the things you need to ensure among a bunch of others when you're trying to automatically provision this type of code. So we came up with a solution for this particular case where we need an automatic deployment of infrastructure, but we need to also maintain the standards we're accustomed to by working on our centrally managed Terraform code base by hand. And the solution, it's pretty simple on the concept. It's just an orchestrated infrastructure provisioning triggered by the onboarding process. So let's say we have this platform as a service. We have a centralized, just think about a centralized sign-up page where clients, after all the pre-sales is done, they're gonna, and that triggers some business processes that we're gonna call the onboarding process. After the onboarding process is started, part of it is to deploy the actual infrastructure that the clients is going to use. But one thing is to generate the code and deploy the infrastructure, and the other thing is to make this, again, automatic provisioning up to the same verifications we have by our centrally managed code base. Just for the example, just to make that code base available to the tech ops team so it can be fixed if anything goes south. So again, the solution we're trying to build here is it's an orchestrated infrastructure provision triggered by the onboarding process. And it's a very simple process in the sense that it doesn't really have that many steps from a high level perspective. So the client signs up, then the Terraform code is generated, then the infra is actually deployed via a Terraform apply, and then you start gathering your profit. So it sounds very simple. There's a bunch of stuff in the two middle steps that we're going to be actually getting more detail. So the orchestration, quote unquote orchestration platform we've been using due to the really tight time constraints is Jenkins. So the whole idea behind this is we would have the actual main central application have to trigger the onboarding process and trigger a Jenkins pipeline or process or job that is going to be actually doing that code generation and Terraform apply and all those verification steps we wanted to hold this infrastructure against. The idea, again, the app is going to be triggering Jenkins via a JSON file. So the whole information on what to build or the parameters that this is going to be, that Jenkins is going to be triggered, it's going to come in a JSON format. And then the JSON, well, Jenkins is going to provision everything. Then it's going to turn back out success message and go email the clients and say, hey, your infrastructure is ready. You're completely set to, well, this is your access and you're completely set to start developing in your platform. So let's start getting some more detail. So as the Terraform code is generated, the whole idea is that we have a modularized code base. So this modularized code base, it's pretty much one of the best things we've got so far, or one of the best things I get from Terraform, is that there are no really, there's nothing set in terms of abstraction models and abstraction levels. So you're completely free to define your own abstraction layers. So by modularizing your infrastructure, you get into a point where you can start building your platforms and your applications using building blocks themselves. So that's the first thing about the Terraform code, and well, one of the reasons we use Terraform. The second very important part about the Terraform code generation, it's the templating. So we're going to be using templates, right? And we're going to be boiling down to make this process as similar as the human version of it. So we're trying to emulate what our tech ops people or the team itself is doing. We're trying to build a complete, an infrastructural piece, a complete system, or for a new application and stuff. We're trying to do that via templating. And everything, it's going to be handled by a really simple Python module. So drilling into, again, the modularization, if we go into the Terraform, its most basic building block or its most basic level would be a resource. Now, a resource is what's being provided to you by a provider. And it's going to be your basic building block. So your S3 buckets are going to get there. It's going to be just a bare resource. Your auto-scaling groups, rules, security groups, firewalls, everything that you can do on your cloud vendor, you're going to be able to do that here. And even so, the fact that this is this stock is heavily focused on Amazon's web services, this can easily be applied throughout any other cloud vendor that it's mature enough to allow you to do your full provisioning via Terraform. So next step, it's standardized modules. So the important part in here is that we don't use bare modules to actually build our applications. We use them on the first layer, just in the first layer. So the big thing here is that on the side of the standards themselves, we're going to be wrapping those resources up and coding in, again, some standards for it. Let's say you need all your buckets to be encrypted at rest. So instead of using just a bare AWS resource or AWS S3 bucket as a resource to build your application that's going to be having buckets, you can build a module around it that's going to have all that built in. It's going to have the encryption built in, the algorithm that's gonna be built in already. So, I'm sorry. So in that case, even in a business as compliance heavy as the client I'm working with is, you can still rest assured that if you're coding your standards and if you define your abstraction layers well enough, you can rest assured that the infrastructure that's coming out of it is coming compliant with all the internal or external regulations you might be subjected to. And it's one of the most important things that we want to guarantee with this Terraform codebase or this automated process. Another big on example for us, it's let's say the scaling policies that we need to be completely resilient, available, and gluten-free, and all that jazz that every operations engineer already gets. And now the next abstraction layer, when you have all these building blocks that have all your standardized policies built in, you actually start building your applications. So in this case, we will see the application as a complete template of what you want to build. So in the case of this platform we want to build in, we would have the standardized version of an ASG, the standardized version of a RDS that might or might not, depending on the environment, need multi-AZ deployment. You will not get the bare bones S3 bucket, you will get the encrypted one with the right keys, and all that to make sure of it by having everything used, every application template or application itself, as we call them, use a standardized module instead of the bare ones. There's some limitations on this, and we'll get into that a little later, but current HCL, actually, it's a little bit restrictive in the sense of what you can or cannot do as a, when building modules, and most of it, it's getting fixed in Terraform 12. But again, we'll just dwell a little bit more into that. So when you have your application template completely set, the next abstraction layer will be a service. Now, we like to have all the infrastructure, all the infrastructure we have completely set in quote unquote stone per each environment. We want to be able to modify certain values or certain parameters of the infrastructure independently across the environments. So if we want to do a change in, let's say, a dev level environment, we can do it without affecting everything else. And this will come in handy when we start doing more continuous integration between the Terraform Codebase and the actual application code that's going to run on top of the infrastructure. So again, these services are environment specific, but they're just instances of the actual application template. So in that sense, in that sense, you have your dev application completely set in stone, and you can modify your prod ones and everything. And this is how it looks like. This is not the real version. This one I prepared for the talk to do NDAs and all that stuff. But this is how it would look like. So you can see in there that we have the application templates. We call them just applications. The modules we built in with all of those standards, and the actual services that are going to be the final abstraction layer. And think of it as an instance of a class. Just we built the class itself inside the application template, and we're instantiating it per environment. So in this case, we're going to have a dev environment, a QA environment, a user acceptance testing environment, and a prod. This may or may not be fully ephemeral or permanent. That depends on the case you're working on. In this case, it's going to be permanent. All those environments are actually long-lived. So this is going to be the topmost layer. So this is going to be the final instantiation in the class. So in this case, we're saying that the first customer we onboarded on our platform-as-a-service offering is Evil Corp. I hope you guys get the reference. The person that's in there, you got the actual source that's going to be the class you're going to be instantiating this from. And it's inside the last folder applications I showed you, and the client platform, it's going to be called like the actual class of it. The environment is going to be production, because in this sorts of offerings, it's in your best interest to offer both a real version of the platform and then a sandbox version, because some clients like to be able to test your service and whatnot without actually breaking anything on their end. So that's why that environment it's set there. The region, which in this case, we're gonna use the most cluttered region there is in Amazon, which is US East 1. The name of the organization, it's Able Corp again. The main username, it's Senior VP of fictional Senior VP of Technology, Tyrell Wellick. And the password is going to come through the actual command line because, again, storing this kind of information on a version control system, it's a big no-no. And the plan, I forgot to add pricing. It should have the pricing plan that's called the premium or large or the enterprise version. Because again, in those sorts of systems, depending on your business case, you might want to have a tiered service. So for example, one client will get full-on computing power for a full huge data processing tool that's going to have a bunch of clusters, and then there's another one that might be a startup that want to use your platform that's just going to have the entry-level version of it. So these are one of the several considerations we might take when approaching this. So now the actual template, if you see, it's just the same class instantiation. It's just the same file but tokenized. Instead of having the actual values there, we're having some sort of tokens that are going to map to how the information is being passed down to this automatic Terraform code generation. So in this case, well, again, you have some levels, and again, your password, it's not going to get there because, again, we're going to generate this code, remember, and then store it in our centralized code base, and passwords in there is a big no-no. The JSON itself, it's going to just have the same levels that the template is, it's being used on. So you see your environment, your region, the organization as an object, you have the name, your pricing plan, and username and password of the main user, even though you might, through your backend, frontend, whatever, are going to allow your client to build more. You actually, well, in this sorts of systems, you want to have the base initial access set. And how are we going to pass all that? Now, again, we're using Jenkins, and it has its own set of problems. It's not the ideal solution, and we'll dwell a little bit more into that a little later. But again, due to tight schedule, we got to use Jenkins, and there is this the plugin called the generic webhook trigger. So what that's going to help us to do is having our main application, our onboarding process, called the Jenkins process, and actually start triggering all of this, but sending a JSON as a parameter. Now, when Jenkins gets this, and it has both the template and the actual information on how to render the template, there's come our nifty, thrifty Python module. It's a really simple module. So down here, you would see it would the Python rendering module would go through each line, and whenever it finds these tokens, it's going to map the let's say the general.environment. Actually, it's lacking a .name in there, to the JSON. So this is one of the things that we built by convention. I'm pretty sure there are better and cleaner approaches to this. But to the extent of our current business case and time schedule, this is going to work just fine. So we build a convention out of it. Right, so for Python, it's really gonna just take those tokens and search for the value in that level that it's in the actual JSON file. Whenever you have that, you have rendered your main file. But the thing is that it's not only the main file. So see, when we're building Terraform, we're building several again files. We have a centralized backend. Let's say that we have that on S3 in order to be able to have a bunch of us working on that without having to synchronize that local state, because that actually it's kind of a mess. Then we're going to have our main file, which is the template I just showed you. That's completely, let's figure out it's completely rendered. And the outputs, that it's more geared towards a manual process. The outputs, it's something you would generally have for an operator that's either applying Terraform or to build reports for people to actually see the results or the names of the actual infrastructure pieces you're building. And and it's your variable file. In this case, we're just gonna declare our variables. One of them is gonna be the password that we're gonna pass via the CLI. So now the actual deployments of the infrastructure. The actual deployments, it's in theory really simple. You have your Terraform code that it's gonna be well, we're going to have, whenever Jenkins, it's going to execute these commands, it's going to have the full Terraform codebase at its disposal, so it can dispose of all the modularized things we already have. Then it's going to do a Terraform init, of course, not require input, and the Terraform plan that's going to go through an actual plan that we use for auditability. And again, we're going to deactivate the input because, again, running Terraform and automation has its own set of rules or best practices, and that's one of them. Then another part of the process, it's gonna hit Terraform apply. So what this is gonna do is that this is going to actually again deploy what our HCL is expressing and all the pieces of infrastructure, and you would have your pieces. But remember, platform as a service is not just the infrastructure. It's all the software solutions we, as a company or as an outsourcing company, are building for the actual client. So again, this part of the provisioning, it's a little bit out of the scope of the talk, but it's just think about it on how you deliver machines through an automatic inventory dynamic inventory in Ansible, and that's gonna deploy your software or your RPMs that are gonna start some serverless services that are gonna be your deployed artifacts, and that actually happens after the infrastructural pieces are there. Also part of the provisioning, it's done on the database, there's schemas and everything that the application needs to actually happen. Just by the way, the MySQL provider in Terraform, it's a gift from heaven. And then when all it's said and done, you actually have your working environment. It's just a matter of sending the access to the client, and the client actually start using your platform and your infrastructure and your software artifacts. And one of the things in there, it's this, but you gotta have your schema, your buckets, blah, blah. And then, but then there are some problems with the actual solution. And one of the bigger issues, it's concurrency. What happens if two Terraform plans are being executed at the same time? Because that can lead to trouble. Why if you're trying to build two pieces of infrastructure and you hit some AWS soft limits, and that blows your whole provisioning over. Another problem, and that's one of the biggest things, is Jenkins, it's not really the best solution as an orchestrator for an actual feature that's gonna be critical mission for the actual business. So this critical systems, that's not really the use case for Jenkins. Because it really lacks some safes or some guarantees that other orchestration platforms or engines are able to actually do easily, like circuit breaks, flow control, retries. Again, being able to just have one plan being applied at a time. And here comes what the solutions for this might be. We have so far built this. There's some things in the roadmap. And one of the first things is just not use Jenkins at all. We're completely aware that that's pretty much the worst. It's not really a good design choice, right? So there are really good engines that are available that allow you to have some workflows. Again, the simple workflow service from AWS, that it's anything but simple. It's a really good choice. And if you're more open source, Cadence from Uber, it's actually a great tool to model and execute long-standing business processes, which again could give us a little bit more control over flow. Terraform 12, we have that on the roadmap. There are some limitations in the way we build our infrastructure. There are sort of workarounds that Terraform 12 is going to be there for. things like feature flags or stuff like that. Let's say a customer just wants certain parts of the infrastructure instead of the whole deal. Another big thing to use would be the support of Terraform Enterprise if the budget's not a constraint, because that gives you a lot more governance into these standards and all this security concerns and compliance concerns. And the other one, it's one of the things I really think that it's important for you to get from this talk. It's to build self-service platforms. The more we automate these kinds of deployments, the less responsibilities we have on them and the less dependency we have on them. And that's one of the missions in DevOps or DevOps consulting, because again, you would be, teams will be more empowered and will be able to deliver value faster and all the jazz. And think of a world where you can just leave everyone write their own Terraform code and be completely sure that they're not going to deploy an unsecure thing or an out-of-compliance thing. So that's, again, that's on the roadmap. And as a business or functional piece, this really helped us understand how to build completely self-service platforms and the amount of automation and work that needs and how we can apply it to increase the empowerment of our development teams across all the organization. And that's basically it. So, well, thanks a lot. I think I've been rambling about for most of the time. I actually ended up 3 minutes short. But hey, thanks to the guy at HashiCorp, and thanks everyone for having a listen to this.
Thank you. We've got a couple of questions.
All right, that sounds good.
Okay, do you utilize workspaces in the templating you're talking about?
We're currently not yet adopted to workspaces, but it's one of the things we're envisioning to do shortly.
It says, why not utilize TerraGrunt or similar for expressing those variables rather than doing the self-created Python injection?
Sorry, what?
Why not utilize TerraGrunt or similar for expressing the variables rather than doing the self-created Python injection?
That's one of the things we might have missed due to our tight schedule. But definitely one of the things that we'll need, actually I forgot to add that on the roadmap, is to actually get rid of that custom folky template rendering and variable injection on it. So actually that's a very well advised taken.
All right, and then does the Jenkins job do a replace of the variables in main.tf using the data in the JSON?
Yes, that is exactly. So here's the deal. The Jenkins, one of those Jenkins jobs is executed and it takes the data from the JSON, and what it runs is actually this Python module that's gonna generate that folder or that set of files while rendering the template. So it is actually executed by Jenkins. Again, Jenkins, it's not the best solution for this. And as long as you control the runtime of it, you can use way better suited orchestration engines in your solution. But at the end of the day, the idea is just basically the same.
Awesome. Yeah, there's a comment that says that they're anxiously awaiting for each logic in Terraform.12 since it simplifies a lot of the extractions you're doing.
It's insane. It's going to be insanely good. Like I've been trying to even push for the early bird preview mode for us to be able to actually start migrating things towards that. Because again, the modularizability, I'm pretty sure that's not a word. But that capacity of being able to build modules and reuse them, it's going to go through the roof with Terraform 12. Again, we're getting more logic being expressed in here rather than being a concurrent, everything is a deployment. I mean, the control flows, the for loops, even with enterprise, with the remote plan and apply, it's going to be huge for us.